Okay, so now we're going to move on to antiderivatives of exponential and log integrals. So let's start with the integrals involving the natural exponential function e to the x. Okay, since the derivative of e to the x is just e to the x, then if you integrate e to the x, you're going to get e to the x plus a constant. But there's also a general form where you have e to the u du. And so to get a problem in that form, you may have to manipulate it with a constant like we did before. So we'll see an example like that in a minute. Okay, let's start with a problem that involves just e to the x. Well, here you have, you want to integrate x plus e to the x dx. Well, you already know how to integrate x with the power rule, so that would just be x to the squared over 2. And then you integrate e to the x just with e to the x, and then you add your constant. And that's how simple that is. Integrate x with the power rule, and then integrate e to the x with the e to the x rule. Okay, here's another one. Here you have 5e to the x minus 2x plus 1. Well, the integral of 5e to the x would be 5 times the integral of e to the x, and the integral of e to the x is e to the x. So when you integrate 5e to the x, you're just going to get 5e to the x. Now, when you integrate 2x, remember the integral of 2x is just x squared, and this is a minus, so it's going to be minus x squared. And then when you integrate 1 dx, remember you just get x, and then plus a constant. So that's the integral of that. Now let's look at an example involving the general form. Okay, so here we have 2x e to the x squared dx. Well, the key is noticing that you have e raised to a power, that is a function of x. So you've got e raised to a function of x here, x squared. So when I see that, I think this integral, e to the u du. So if I think that integral, then of course the u would have to be the power x squared. So let's give that a shot and see what happens. Let's let u be x squared. Well, then remember du is just the derivative of x squared times dx. So that would be 2x dx. Well, now if you go back to this problem, the 2x and the dx together form the du. So right here, this portion right here, I rearranged it for you so you could see it. This is actually du. And if that's du, and of course we already knew this was e to the u, so this integral can be written in the form of e to the u du, where u is x squared. And now, using this general formula up here, the integral of e to the u du is simply e to the u plus a constant. And then remember, always go back in and replace u with what you used for the substitution. So it would be e to the x squared plus a constant. Okay, now here's a similar one, but it's not exactly the same. It requires a little more work. Here we have x e to the 4x squared. Well, again, I see e raised to a function, so I'm going to let u be that function. So I'm going to let u be 4x squared. Well, du would then be 8x dx. Okay? Now notice here I have x dx. I don't have 8x dx. So I need to figure out a way to get an 8 in here. Well, remember that trick. You can multiply the inside by 8 and leave the 1/8 on the outside. So if I multiply the inside by 8, that would give me an 8x dx. And I can do that as long as I have a 1/8 on the outside. So now this is e to the u, and this is du. So right there is e to the u, and then this portion in the parentheses is du. And then I've got the 1/8 on the outside. So that's just 1/8 e to the u du. And then you know when you integrate e to the u, you just get e to the u. So it's 1/8 e to the u plus a constant. And then the last step is just to replace u with what I set it equal to up here, 4x squared. So I get 1/8 e to the 4x squared plus a constant. Now, this next example is to show you that just because you see an e or e to a power, that doesn't mean you're going to use the exponent rule. Let me show you. See, here I have e to the 3x, and in here I have e to the 3x plus 1 to the fourth. Well, I want to think of this as the power rule, because this is actually u to the fourth, where u is e to the 3x plus 1. So let's let u equal e to the 3x plus 1, and then du would be the derivative of this times dx. Well, the derivative of this would be 3 times e to the 3x, and then so we would have du is 3e to the 3x dx. Well, let's look at how we can, let's rewrite this. Let's just rearrange the order a little bit. So if I write it like this, I have this function to the fourth power, and then I have e to the 3x dx. But that's not du. This right here is not quite du. I'm missing the 3. So what I'm going to do is I'm going to multiply the inside by 3, and remember you can do that as long as you multiply on the outside by the reciprocal, which is 1/3. So now this right here is, I'm sorry, just a minute. This right here, this first factor, e to the 3x plus 1, is u. So I have u to the fourth, and then this right here is now du. So I actually have 1/3 times the integral of u to the fourth du. And that can be solved using the power rule, because when you integrate u to the fourth du, you get u to the fifth over 5. So I get u to the fifth over 5 times 1/3, which is u to the fifth over 15. Notice, don't lose your constant. Okay, and then the last step is to replace u with what we set it equal to, e to the 3x plus 1. So I have e to the 3x plus 1 raised to the fifth over 15 plus a constant as my final answer. Now, I took a little detour here to show you another one like this. You could do this one like you did up here, but actually this one's not raised to a power. So since this e to the 3x plus 1 is not raised to a power, you could just distribute the e to the 3x through here by multiplying. So e to the 3x times e to the 3x is e to the 6x, and then e to the 3x times e to the 3x, e to the 3x times 1 is e to the 3x. So then I get this. Well, it turns out that if you want to integrate e to the 6x dx, and you want to integrate e to the 3x dx, well, there's actually a little formula you could remember if you wanted to. E to the ax dx is 1 over a e to the ax plus a constant. So what I'm saying here is if I want to integrate e to the 6x dx, then that's the same as 1/6 e to the 6x. And then if I want to integrate e to the 3x dx, that's the same as 1/3 e to the 3x. And then of course you add your constant. So that's sort of a shortcut to the answer. Now actually this rule comes from substitution. Let me show you that. If I actually said let u be 6x in the first integral, then du would be 6 dx. So how would I rewrite this first integral? Well, I would insert a 6 on the inside, which would force me to put a 1/6 on the outside. Well, then this could be thought of as 1/6 of the integral e to the u du, and we know that when we integrate e to the u du, we just get e to the u, so it would be 1/6 e to the u, and then since u was 6x, that would give me 1/6 e to the 6x. And basically you could do the same thing for the second integral, but you would let u equal, or actually I chose v this time so it wouldn't be confused with the same variable. So you could let v equal 3x, and then dv would be 3 dx. And so I did the same thing here. I multiplied the inside by 3, so I would get a 3 dx, and the outside by 1/3, and then that gave me 1/3 e to the v dv as the integral, and then when you integrate that, you just get 1/3 e to the v, and then v was 3x. But of course, you know, like I said, these formulas down here just come from, this formula right here, it really just comes from what I did up here, just doing a substitution. Okay, 1 over x dx is actually the natural log of the absolute value of x plus a constant. So if you have an integral of this, 1 over x plus 2x, well, when you integrate 1 over x, you're just going to get the natural log of the absolute value of x. And then when you integrate 2x, you're going to get plus x squared. And then, of course, you get your constant. Here's another one. If you integrate this, well, you know the integral of e to the x is just e to the x. And this is actually minus 5 times 1 over x. So if you wanted to, you could actually say this is minus 5 and then just say times 1 over x. Well, minus 5 times 1 over x would be minus 5 times the integral of 1 over x, and the integral of 1 over x is natural log of the absolute value of x, and then you add your constant. And then here's another one. This is 5 times 1 over x. So if you integrate 5 times 1 over x, it's 5 times the natural log of the absolute value of x. And of course, you know how to integrate x, and then you add your constant. So that's the simple form. There's also a general form, just like there was for e to the u. The general form is that when you integrate 1 over u du, it's going to equal the natural log of the absolute value of u plus a constant. Now this is when you have 1 over a function. Okay, so here I have 1 over a function. Actually, I have 3, but you can pull the 3 out here and think, okay, well, that's just 1 over x minus 5. So if I were to let u equal x minus 5, then du would simply be dx. So with the 3 pulled out, then this turns out that this is just 1 over u du, and with a 3 on the outside, and then you know how to integrate 1 over u du. That's just natural log of the absolute value of u plus a constant, and then of course your 3 that was on the outside comes along. And then at the end, we can replace u with the substitution that we used. So replace u with x minus 5, and that's your final answer. All right, well, here's another one. This one, I've got a function in the denominator, and of course the key is it's not raised to a power, so I wouldn't use the power rule. But if I let the denominator be u, so let u equal x squared minus 3x, then du would be 2x minus 3, and I forgot the dx, but it'd be 2x minus 3 dx. Okay, so now, look, this works out perfect. See, this part right here, 2x minus 3 times dx, that's the du. And then this part down here is the u. So this is the integral of du over u, which is the natural log of the absolute value of u plus a constant, and then just replace u with x squared minus 3x to finish it. So, and that gives you the answer. Okay, this one here says x squared over x cubed minus 1. So if I let u equal x cubed minus 1, then du is 3x squared dx. And so I need a 3 in here. So if I multiply the inside by 3, then I've got 3x squared dx. And when I do that, I have to multiply the outside by 1/3. And now we at 3x squared dx, remember, is du. And this denominator is u. So I have 1/3 du over u. And then when I integrate that, that's going to be 1/3 times the natural log of the absolute value of u plus c. And then the last step is to replace u with x cubed minus 1. Okay, let me finish this video by just comparing two similar integrals. I'm going to do this kind of quickly. Notice here the denominator is raised to a power. But notice down here that you have the same denominator, but it's not raised to a power. Well, here I can rewrite this as x cubed plus 5x to the negative 3 power times 3x squared plus 5 dx. Well, you'll notice that 3x squared plus 5 dx, if u is x cubed plus 5x, then du is 3x squared plus 5 dx. So this can be solved simply using the power rule. So you can finish the rest of it there. But the next one, since it's not raised to a power, if I let u equal the denominator, then du is 3x squared plus 5 dx. Then this is simply going to be du over u, which is the natural log of the absolute value of u plus a constant, and then you can finish the rest of it. But notice these two look very similar, but the key in understanding that this one is the power rule and this one is the log rule is that this one, the denominator is raised to a power, and here the denominator is not raised to a power. And I'll continue with some more examples on the next video.